and welcome to a new series of spectacular episodes of microcoil and magic circuit research, specifically for the Everlasting Lantern project. Okay, and what this is basically it's a little kind of setup that I made up when I was away in the evenings and experimented around with. Well, I made up several different ones, and this is basically the best one I had using, guess what, one of these little yellow ring cores. Okay, this is actually the original winding under here is one you actually wound for me. Okay, and I've just added some extra windings on there because that's all I had when I was away available. And basically, with using this lovely little breadboard, and we have a little greybox transistor here, and this is these are new 5 watt resistors, ceramic, really hardcore. And what we'll have here is we have a large electrolytic capacitor. It's not a supercapacitor, but it basically can store about 1.7 joules of energy, which is actually a very small quantity of energy. That's about 1.7 watts in 1 second. Okay, that's a maximum. I'll actually be demonstrating this using much less energy than that. I'll be demonstrating with using around about 1 joule of energy. So that would be like a 1 watt LED on for 1 second. Okay, and basically that is the energy input into the magic circuit. Okay, this is magic circuit number 5, which is with 2 coils, and we're powering a 100 watt LED. Oh, and also we have a lovely little switch here as well, where we can turn the circuit on and off. So all is very grand. Okay, and I would also like to show you. I've got loads of stuff, but we're now. I have a new Lush multimeter now, and we can basically. It does everything I want it to do, including the temperature very accurately. Very wide temperature going down to minus 50 to 1300 degrees with probes, various probes, industrial standard probes. Okay, and we can test frequencies and all sorts of stuff with this one. This is really grand one. So this is my kind of new one. Because the other one I actually borrowed from my dad, and I've had to return it. So I bought a new one. Okay, as well as I've already got the oscilloscope and stuff like that. Okay, so what we're doing here is we're basically testing a capacitor. This doesn't really have much energy compared to the supercapacitors at all, but it kind of demonstrates what happens when we add a decent capacitor to the magic circuit and a micro coil. And this is absolutely brilliant stuff. Okay, which I'll demonstrate in the next video. Because these series of experiments all about the micro scale. So all the kinds of things I've made, all little circuits and coils, including the pot cores, which will be coming later in this in a couple of vids, because we're just testing what the best of the old technology we had before. And then we're going to demonstrate the new stuff and some thermoelectric specials as well. Right, so on we go. We'll do a quick recap of what we're doing here. We have a micro magic circuit number 5 with a grey box transistor, which are brilliant. And for this small scale stuff, we have a coil here, very small. If you see, that's my thumb in comparison. So it's a very small size indeed. and this winding ratio is about 2 to 1. We're going to be powering this 100-watt LED, and we can plug different types of LEDs into here, which we'll be demonstrating. And this is a electrolytic capacitor, a large one, but it only goes up to about 10 volts. Okay, there we go. You see, 10 volts. Okay, we will be powering it up with this 2-cell lithium polymer battery, which I've fully charged it up, so this puts out about 8 volts, okay, into this circuit. And we have a switch here where we can turn the socket on and off and charge the capacitor at the same time, right? So let's get it on, right? Now, this is the most amazing thing. Okay, now I'm not. All I've got is got one of these jumper leads in the negative there, and then all I'm gonna do is basically this shows you how fast this charges up. As I said, we're only going to be storing about 1 joule of energy. That is basically 1 watt of energy, like a LED, for 1 second. That's all. And the magic circuit is going to resonate, and it's going to basically give us some spectacular results. Okay, so here we go. Watch this, and all we're going to do is literally touch the terminal. Okay, here, just for a second, and we will see. Okay, so I've got to do this while I'm doing this. We'll try and get it. Can we get it? It's so small. There we are. Look at that. Look at that. Look at that. Okay, so that's purely running from the capacitor at the moment. Okay, and we just literally touched that battery. It put 1 joule of energy in there, and now we released it over that time in this 100-watt LED. Okay, so I'll just do it again. Okay, here we go. Just touch it. There we are. Look at that. Okay, and just to prove that this is just the energy, this is just 1 joule of energy which is coming out of there, and there's no connections. What we're going to do is this time we're basically going to switch this off. So we switch the circuit off, and we're just going to charge this capacitor. And all we're going to do is just, you see here, we just touch like that, touch it. Okay, now it's charged up. Then we remove the battery completely. There's no batteries at all. And then basically we're going to power the circuit from that teeny bit of energy. There we are. Look at that. Isn't that great? See? There's no wires. It's just all the energy is resonating backwards and forwards, coming out the LED. Okay. And this is just this is a 100-watt one. Okay. Now, to show you how amazing this circuit is, we remember this. Okay, this is the the rubber band battery. Okay, you know, from all of those months ago. We're going to try and power this circuit, this coil with this with this dead battery. And this is about 6 volts. I think it's about measuring 6 volts. We've got nothing in it. Okay. Right. So we're going to try and power this circuit. See how this particular circuit is. And by the way, this isn't the best circuit. The best circuit was the one with the 3rd channel. Okay, the 3rd winding with the bridge diode. So it's just I've run out of prototyping boards at the moment, but some more arriving in the next couple of days. Okay. But anyway, yes, we're going to try and power this with this very dead battery from many months of research and all sorts of stuff. Okay, and we barely could get a 10-watt LED going when it was going good. Okay, and look how far we've come here. So what we're going to do is get that on. It's going to be difficult. Okay, can we get it on? Okay, Yeah, we've got that on. There we are. Look at that. Look at that. Okay. Look at that. Well done, son. Look at that. Super battery. There we are. And then basically we're going to remove that battery and it's just going to run from that capacitor. Okay. Resonate with a capacitor, the energy in the circuit. Okay. And the LED. There we go. Off. Battery off. Dead battery off. Okay, look at that. I think that's pretty spectacular for this little super battery. Okay, so yes, very amazing stuff. So even from very dead, super dead batteries, we've done shitloads of stuff. We can still get the energy out of it. Okay, and by reducing this the control resistor. Okay, it's 10k at the moment. Okay, but if we had like lower, or a pot on there to adjust it down to 1, we could actually get it brighter for that actual energy. And we can, as I said, I've demonstrated we can get some very low voltages and stuff, and do spectacular results. But the thing is, now it's super micro. As I said, it can virtually fit on the palm of my hand. That's my palm compared to the gubbins. Okay, it's tiny. Right. Okay. So let's basically get this this thing back on. Hang on. Let's connect that on. Yep. Okay. That's the 8 volts again. Save you for some more spectacular experiments as the benchmark. Yes, what we're going to do is we're going to we'll just demonstrate this again. Right, we'll just touch there like that. Yeah, you see, watch this. Watch, you just touch it. It's very hard to do when I've got 2 hands, but there we go. There we are. Okay, look at that. See, that's not connected at all. That's just purely running off there. As I said, the higher the voltage you get to that 10 volts, the better this performs. So you try and fill the capacitor as much up as possible. Okay, so that's a 100 watt LED. Let's get some other wattage LEDs on. What we have is one of the new 20 watt cobs. Okay, it's a bit more difficult than crocodile clips, but we will do it. So I really need 2 hands to do this. I've got to quickly do this. Right, yeah. So the 20 watt is going on. Okay, so the thing is, the 20 watt uses 5 times less kind of energy. So basically we can stretch that energy out even more. Okay, so we've got that one on now. This one runs about the same voltage as that. It's normally about 34 volts to 36 volts. Okay, so here we go, straight on. And there we go. That's really grand, isn't it? So you see, that's lasting much longer, okay, than the other one. Right. So yes, what we're doing is we're going to be testing a variety of different types of LEDs. Okay, just showing you how adaptive this circuit is on the micro scale. Okay, we have all sorts of different LEDs. Okay, to demonstrate, and they consume less powers as we go down. Okay, so here's the and we see how fast that actually charges up. So what I've done is I've rigged it up. Okay, so when I basically press this button, the power goes into the circuit, powers the LED, charges that up instantaneously. And then what I do is I then switch it off. That isolates it from the battery because I've only got one hand, and then it's purely running from the capacitor. And we can see the different kind of run times. Okay, with this spectacular self-resonating circuit with the capacitor and the magic circuit and LED, which is bloody grand. Okay, okay, let's do it now. Okay, so we're on. You see, and that's really fucking bright. As I said, obviously the phone can't actually demonstrate that. we can actually have that much brighter if we want, by just reducing the resistance on the base of the transistor. Okay, but for this demonstration purposes, we're just using a fixed resistor at 10k, so we can see it demonstrating, and so it doesn't absolutely completely blind me and blind the camera as well. Okay, so now this basically disconnects, switch this off, so the battery is no longer connected, and we're basically purely running off that capacitor resonating in the circuit. Okay, and basically it kind of slowly dies down. It lasts a lot longer than the 100-watt LED, obviously, because it's a lower wattage. Okay, until it fades away. Okay, so let's get another LED on. Okay, I think we should get the next one. That's 20-watt one. This is a 10-watt. These are really good. Okay, it has loads of LEDs, but it's only 10-watt. Okay, so we'll get that one on. So 2 seconds while I do this. So it's still difficult with. It's best to do it with 2 hands, and it's a lot quicker. You know. There we go. Sure. There we go. There we are. And as I said, basically, I made the lighting I installed. I ended up installing in the cottage, which they were using candles, man. Okay. So although they had a small solar panel and quite a dead car battery. With these things and adding some kind of resistors and diodes, I gave us some great lighting with 2 different light settings. But I'll tell you about that later. Let's get on with this. Okay, so on we go, straight on. Really lovely and bright. Okay, this is half the wattage of the round ones. We're going to isolate it. Okay, so the battery is no longer connected. Okay, and we'll see how kind of this long lasts. Okay. See, lasting quite much longer, slowly fading away now. Okay, but as I said, this is amazing. This is just 1 joule of energy. Okay, so it's absolutely kind of phenomenal stuff, right? And it's the same kind of instant kind of charge of this capacitor all the kind of time. It's just I don't have 2 hands. So we'll get that one off. I said I really like these ones. I just wish they would have had like a big round one like that with all of those LEDs, because they do perform one of the best. Next one down is this 6-watt strip. Okay, so we'll get that rigged up. I'll end this one and continue with the next. So now we've got the 6-watt one on. As I said, the 6-watt and the 10 watts, okay, and this is a 4-watt one, and this is a 3-watt one. The 4-watt ones, unfortunately, they run out of a warm white, so this is just a white, okay, but it's still canny. It's not as cool as a cool white, okay. And these all use kind of about 12 volts, okay, instead of the 20-watt LEDs and 100-watt LEDs, which use base 34 volts. Okay. So yes, let's do this again. Okay, let's get it on. There we go. And then we're going to disconnect it from the battery. Okay, pressing the switch, and just to show again, it's completely no battery there, and we're basically running wonderfully. Okay, and then basically it gradually kind of dies down. Okay. Using every particle of this kind of energy to maximum, okay, which is brilliant. And by the way, all of this energy you're seeing is basically negative energy. It's running backwards. It's backwards electricity. All of these LEDs and power from backwards electricity. That's what we're doing. The connection on this circuit is backwards electricity, which is completely 100% proved by many previous experiments. Okay. And tests. So let's get the 4-watt one on. Okay. Okay. And as you see, as we go down the wattage, okay, we actually get more and more time. Okay. that's what happens. It's kind of that's how it kind of works. So let's get it in. Right. There we are. So this is a white one. As I said, it's not as an offensive of a cool one. Oh, we've got to connect this up again. Right. Right, we're all connected up. Okay, so let's get this one on. Right, switch it on. You see, and you can see that we're actually kind of getting maybe kind of brighter as well. There we are. Disconnect it from the battery completely. There we are. See, and we're running. And then you see, so this one's a good runner for this. As I said, exceptionally small amount of energy. As I said, hopefully we'll get some. The 4 watt ones are the original ones I wanted. I really like this one, but kind of round, and it would be brilliant. So the next best thing to that is basically this little fried egg, the original fried eggs that I couldn't really, haven't really kind of used really for much. I kept on just kind of blowing stuff up and frying loads of stuff, but now we've got it absolutely perfect. We don't fry nothing, okay? And it does help having a fixed resistance, okay? But we can have a fixed resistance, but have a pot as well, so we can actually play about with stuff as well. So let's get this one on, okay? And because we're basically going down the kind of wattage, but we're getting better results, okay? And we're getting brighter light as well for it, okay? So this is me kind of flying egg, okay? One. Let's get it powered up. Right, there we go. Connect it in, like so. And then we get that in, like so. There we are. There we are, in. Let's get the flying egg, okay? The flying fried egg on, okay? This is a 3 watt one. And now, for the everlasting lantern, these are looking like my favourites, okay? So we get on. Oh, we're going to have to end this now, okay? Right, okay. So now we have the flying egg one, and that's putting out a lot of light, okay? So for the everlasting lantern, I think the lower wattage stuff is much better than the higher wattage, but it's still very impressive. And as I said, if you had a crystal cell where you have a constant output but very low amount of energy, okay, I think all these other LEDs, these higher ones, would work absolutely brilliant too, okay. But what we're doing here is we're going to be, with Everlasting Lantern, we want to be able to recharge it, well, one of the versions with a thermoelectric element, a TEG element, okay. And what that does is the idea is it basically recharges a capacitor for a couple of minutes, and then basically you can pick it up, take it away, and then you get a whole night's worth of light, okay? And by testing it with a very small amount of energy and maximising it and testing the run times, we can basically kind of fine tune stuff, okay? And by the way, and this is just a coil winding, a ferrite core winding, okay, in a special proportion. But with this magic circuit we've evolved, okay. The pot cores are next, okay. So let's basically just isolate this from the battery, okay. The final run of this one. There we are. No, nothing. See, not attached. All resonating lovely, and you can see that this one's lasting quite a long time, indeed. And it's gradually dying down and dying down and dying down as it's getting every little particle and electron from this. By the way, this is a tiny bit of energy compared to what's in a crystal cell or battery, which is outputting. You know, this is absolutely spectacular stuff. So I know, let's try and use the dead battery again and see how that is with a flying egg. Okay, very, very fast, super battery. So we'll get that on there. Okay, and we basically have to push. Oh, it's hard to do with with one hand. I tell you. There. Okay. Ah, can't do it. It's very hard to do. Hang on, I'll get it. I'll put the phone down and get it sorted, and then do it. I think that's the best way. Right, I've got my fingers pressed on there. Can I get the power in there? Okay, look, instant. Running off the dead battery. Isn't that beautiful? Isn't that a beautiful light? A beautiful, beautiful light. Okay, let's take the battery away. Okay, there, battery away. Okay, so isn't that grand? It says it's amazing before, back in those days when I thought it was amazing just to get a kind of one of those teeny little like 10 watt thing jobs, piddly bit of light. Whereas now we get loads, and we've got beautiful self-resonation, max amazing, all the juice and everything. Okay, so I thought that was really, really fascinating stuff. And also with micro-sized things, which is brilliant. I'll show you this next lovely little thing. Okay, what this is, okay, is this is a lush little step-down module, which kind of I've been using for loads of experiments. We basically have a voltage on the top and the ampage on the bottom, and this can read down to about 20 milliamps. Okay. So we can meter the energy, we can actually see in real time the energy going into there, which is great stuff. Right, and welcome back. And right, we're now going to demonstrate this beautiful little step-down module. And we're stepping down a battery, a 2-cell lithium ion, which is about 8 volts, 7.4 volts. Okay, and we can basically step it down to any kind of voltage right way down to 800 millivolts, which is 0.8 volts. Okay, and also we can see exactly how much ampage we're consuming as well. This is very, very accurate indeed. It can read all the way down to 30 milliamps. Okay, and anything kind of below that, say 20 milliamps, it will actually appear, because it will be actually on it's just a few milliamps. Okay, so if we want to kind of check that out, very small, if it's just a few milliamps, but virtually nothing, we have to kind of use things like this. And things like the oscilloscope, which we can do kind of tomorrow. Well, we're kind of just running through lots of things very quickly, and this is an amazing little thing to meter stuff and do all these kinds of experiments without frying anything as well, and testing stuff. So what we've done is we've set this to 5 volts. You can see the little adjustment pots there. So we've got it at exactly 5 volts. Okay, and we're going to basically see how much this consumes. So we're going to basically get the battery in to power the module up. Okay, this module uses a very small amount of power, although the LEDs use a bit. And basically it's 5 volts input. So we're going to actually let that power in, and we're into here to charge up the capacitor. And we're just going to, can you see there'll be a little pulse charging up that capacitor. Okay, if we go now. Okay, did you see that? It was like 1 second at 1.36 amps. Okay, at a fraction of a second. Okay, 1.36, but a fraction of a second, and now it's powering it. Okay, so that is actually full now, and this is actually, the LED is what this is consuming at the moment. Right, so it's basically 5 volts. Okay, at 0.00 amps. So obviously it's under 30 milliamps. It's kind of 20 milliamps and under. Okay, so to read that very very small amount of wattage, it's below what this can kind of read. So we're using hardly anything to get a great light from this. So this is absolutely brilliant. So what we're going to do now is we're going to disconnect the power source and the module from here, so it goes straight on. So it's on the capacitor. Okay, so now it's running purely off a capacitor, and basically you can see that 1 joule of energy. Sorry, it's not 1 joule at 5 volts. It's basically 700 milliwatts. 700 milliwatts. Okay, 0.7 milliamps in total can actually do, and that's absolutely kind of brilliant. And this is just the start. Oh, and the reason why we've got this on 5 volts, okay, is for a very specific reason. Okay, and it's because what we want to do is we want to use a TEG element to recharge the capacitor. So this is a very small capacitor. This is not the supercapacitors, which I'll be demonstrating in a bit. Okay, what we want is to use one of these TEG elements. These are new TEG elements, and I've got absolutely tons of them. Okay, pile of them. Okay, to make some nice, pretty beefy thermoelectric generators. Okay, generating tiny bits of power. But anyway, that's for another time. So I'm just going to move on to this next. Okay. Right. So continuing on. Okay. Let's just put this on again. There we are. How that? You see how that just went like that. So it was 1.36 amps for a fraction of a second, and then it's completely charged the circuit. And we remove that, and it's completely running by itself, and we can basically put more kind of power in. There's another bit of power. Okay, so that kind of proves this kind of point. Okay, and now we have the TEG elements here. This is one of the new TEG elements. Is actually a lot smaller than those pellet elements I was showing you running stuff before. They're about that big, where this is like much smaller, yet it can put out a lot more power. Now this one, when you've got a potential difference of 100 degrees centigrade, can put out up to about 3 watts, okay, 3 to 4 watts, yeah, and if you have a temperature of, say, boiling water at 100 degrees and something air temperature 20 degrees, we can generate a canny bit of power, wattage, okay, much better than the other ones. And what I've done is I've actually, because remember what these do is they produce a few hundred milliamps, okay, but they produce kind of low wattage, right, okay, and what I need to do is I need to be able to, the voltage from this needs to be coming out the other end at a voltage which can charge a capacitor. Okay, so supercapacitors are some 2.7 volts and some are 5.5 volts. So we need a constant voltage to do that. Now I could make a magic circuit specifically for that, but you can actually buy an off-the-shelf part which can actually do that. It's very small indeed. And what this is, and it took me a long time to find these, and I got a few varieties, but this is one of the best ones. What this, and you see how small this is, it's bloody tiny. This is basically happens to take a fairly low voltage, okay. I have tested it, I think, down to 0.6 volts, maybe even lower. I haven't fully tested it yet, and it basically puts it up to 5 volts, okay. But obviously it drops the ampage, okay. And what I've done is this matches what that can put out when you've got boiling water and water at, say, 20 degrees. Okay, so this is a maximum of 600 milliamps at 5 volts. I don't know, is that about 3 watts or something? But that's the maximum. But it's a bloody amazing, and it's really small and compact. And I've basically, all I've done is said normally these are these are using like lithium ion cells. But what I've done is I've attached it and soldered it directly to the tag element, okay, to create this lovely little generator, little step-up thing, which we can charge capacitors and all sorts of USB type stuff, possibly even things like mobile phones. And it's so damn fucking simple. And that costs £1 from no, actually less. I think I got this £80, 80p from AliExpress. I got 10 of them, and these cost about £2.50 from another specialist place from Hong Kong. So we've got something really grand here, and I'll actually be demonstrating that kind of next before we move on to the pot cores. So we're going to set that up next and do some interesting thermoelectric experiments before we move on to the finale, the spectacular finale. Right, it's time for thermoelectric generator time. And basically what we're going to do is we're going to be powering something with this tag element generator, and I managed to track down these lovely little things which I thought would be quite useful for tests. These cost about £1, and what they are is they plug into a standard USB port, which we have on there, and we basically have 6 little LEDs which add up to 1 watt. There's no magic circuit, so like 1 watt comes in there and basically 1 watt of LED light comes out. This is evidently about 90 something % efficient at doing that, okay. But what it means is we've got a ready-made little thermoelectric generator and light, and this also has a dimmer on the back. You just touch the back up and down to dim or increase the light. So this is great for basically testing these things, okay. And I've got some other ones which are ones like 0.5 watts, and it's a warm white as well. But it's an amazing little light in itself. So let's basically do a demonstration. So we have our hot water. This is, it's probably boiled about 5 minutes ago. So we kind of fill it up. So we kind of overflow, and because these the tags are smaller than the top of here, what we're going to do is put this basically round tree thing. So it's actually, this is metal, and it basically, the heat comes through here, and then what we do is take a teaspoon of water and we put it on top of there, so the tag element can go on. And with these, the right-hand side is a cool side, and that's the hot side. Okay, but first of all, we're going to put this in, okay, to here. So we'll just do that now. Right. So that's in. Okay. So we have our lovely little USB light here, and we basically put this on top here. Okay, the right-hand side, face side, always goes up, and then what we need to do is put another bit of water on there. As I said, we would normally use the grease, okay, and we get that on like so. Alright, aha, look, there's a light on. That means it's generating power. Let's switch it on. Alright. There, look at that brightness. Okay, so that's 1 watt, because this is these are 1 watt consumption, so it only consumes what it is. But isn't that a bloody amazing? Okay, look at that light. Okay, so that's like a 1 watt LED. Okay, that adds up to 1 watt, and there's no magic circuit, so we're consuming 1 watt at the moment. So basically, every second of this, okay, is using 1 joule, which was exactly the same amount of energy we saw when we're charging that capacitor, but for all of those, like kind of almost a minute on the 3 watt ones. Okay, so that's that's kind of, we expanded it up to 50 times, 50, 60 times. Oh, no, actually more, because we're only using 0.7 at the 5 volts. So yes, we're getting over 60 times more kind of the brightness, the light and the energy. Okay, kind of, that's kind of pretty over unity. So this is amazing. Okay, so as I said, I can actually switch off all the lights in the room, and we can actually use this light as a very, very nice kind of light, and it's all coming from this little thermos flask cup. Okay, and the potential difference of about 80, 70 degrees, with the actual got to end this. Right, so do you think this is a great little kit? I think if this little board was shrink wrapped, okay, may look really nice. We have a very nice product here, which is unique in the world. Okay, it's very low cost to produce as well. It's kind of altogether, it's about what, £2.50 for the target element, 80p, and 80p £1.60. So that is, what, I don't know, three or four quid. Okay, yeah, and we've got something absolutely brilliant here. Okay, and as I said, this will run for a very long time off this. And if we had proper heat sinks with the thermal grease for new silicone, brilliant silicone, the performance is better. But as I said, at the moment, this is actually producing more power than the LEDs are consuming at the moment. And as I said, it only consumes, it kind of draws the power of what you stick on the end. Okay, but we love this light. We love this light indeed. So I'm just gonna show you by switching all the lights off in the room. Yeah, what that produces alone. Yeah. Okay. So there we go. Look at that. I would say that is a really good camping light. Okay, that is much more powerful than most head torches and stuff. I said you can't really see it on the film, but we can kind of shine it around. Okay, you can't see it so much from the camera, but I can actually see quite a lot around in this room. And the more higher we have, the more we can see how much that light is shining. And we can actually dim that. Okay, and we can go up, off, and then we slide it up. Yeah, there we are. Yeah, slide it down, slide it up. It's lovely and tactile. Yeah. So I love this. I love this. This is a great. There we are. We can see all these things here. We shine it over there. And remember, there's no reflector on here. It's actually 120 degrees. If we focused that light with a reflector, we would have an even more tense beam. If we had a lens, we could have a very powerful kind of torch. Okay, and obviously here, this is just a teeny little thermos flask cup. This only takes 300 mils. A litre thermos flask would be miles better. We could have a light mounted on there, and that would be another product. So it's like the kind of a cap would have the light on, and then basically it would last for several hours with one fill of a thing. That's not using a magic circuit, but the only issue with that is you obviously have to have this kind of hot water, and it gradually kind of cools down in this big pan, and that's kind of bulky. We could do like air cooling. I am investigating air cooling, but I really like that. So let's get the light on again, and we'll try and power something else, okay? So I think we should go and try and power a mobile phone, okay? We'll do an iPhone, okay? This would be a great test. So basically, I'll just get a lead. Okay, there's our lead, and we're just going to stick that in. Take that out. Okay, and in we go. Okay, and are we charging? Are we charging? We're not charging. Right, yes, I had a little problems trying to charge this old iPhone 2 up, okay. In the cottage I have with this setup, I have actually charged mobile phones up, but I think I charged mine and I charged friends up as well. So maybe this old one requires the kind of higher ampage, 1 amp or something like that instead of 600 milliamps. Okay, but I'm able to charge the phone I'm using at the moment, but we can't demonstrate that at this point in time. Okay, so what we're doing is we're moving on. Okay, because we can charge lots of USB devices with this. This is why it's very grand. And then what we're doing is we're going to actually power the circuit we were using before with the capacitor. Okay, and this has been running for quite a few minutes now, because I had to. I was checking stuff out and all that. So let's basically get this on. And what I've done is I made this USB lead, which basically goes into here. It's got 2 terminals all soldered up and stuff. So let's basically get this on. Right. So we connect that up. Right. So it's all connected up. Now we are power is going in, and we've just got to let some power in here. There we go. Instantly on we go, and you see that slowly thing because it was filling up the capacitor. Okay, but now we have a wonderful light, thermoelectric light. Okay, which is brilliant, and we've also charged the capacitor. So this disconnects it from the thermoelectric generator, so we're purely running off the capacitor again. There we are, we've switched it off, and now it's completely running off the capacitor again, and you can see basically it's gradually dying away, because obviously there's only like 0.7 joules of energy in there, okay, which would actually run this only for 3/4 of a second, 3/4 of a second, whereas with this one we can actually run it for I don't know, about what, 35 seconds or something like that. So it's about 50 times better. Okay, that's why it's absolutely amazing. So we can demonstrate that by just pulling this out. Okay, if we can do it with one hand. Now we've done it with USB connectors. Okay, we'll have to do it. We'll have to put it down. You know, we can do it. Yeah, here we go. Off we go. Still have a light, completely disconnected. So we've kind of demonstrated a sort of little mini thermoelectric everlasting kind of lantern thing. It's just we don't, we have a very low storage capacitor, whereas we'll be moving on to the super capacitors next, okay. Well, what this does is it proves this recharging with a thermoelectric generator principle. So we'll get that on again. If we can get it on. Oh, tell you. Yeah, it's like I need 2 hands. There we go. See, we're on again. We obviously the water in there will have been cooled down quite a bit by now. I don't know, is it 25 minutes or something like that? Oh, yes, and also we can have this miles more brighter because we're only using a teeny bit of minuscule amount of power. and basically by reducing the resistance here, this is at 10 kiloohms at the moment, k ohms. If we say reduce that down to 1, we'll get miles more brighter because we'll be using more of the kind of energy produced. So we're not actually using hardly any of this kind of energy. So if you want a direct light, it's very powerful. Right, so what we've done this time is we've basically connected in an adjustable pot, okay, in conjunction with a 1k ohm resistor. So before we had a 10k fixed, we have 1k 10 times lower and a pot where we can, this is a 100k pot, so we're going to go all the way down, okay. So it's all connected up to the thermoelectric generator and still running from the same cup, and basically we can let the power in. So we can, this time we can let a lot more power in than when we had the 10k in. So we get brighter and brighter and brighter and brighter and brighter. It's fucking getting really fucking bright there. Okay, so that's going all the way down to 1k. Now if we put like lower, say 100 ohm, we can go even lower and you even use more of that direct power. Okay, but as I said, as we reduce, when we're just purely running off a capacitor, we actually want quite high resistance there, so it lasts longer. Okay, so we'll basically just disconnect it from the thermoelectric generator, which it is now. You can see how fast that dies off, okay, compared to if we have a lower resistance, okay, a kind of less brightness, okay, so we can actually control that brightness, okay, to where it was before, okay, and then basically it lasts much longer. And this is kind of the trick you have to do, okay, and it's all the key about metering out that power just the right way to a magic circuit, you know, and that's running miles longer than if we suddenly turn this up to brightness, but then it fades away really quickly. Okay, but I think that's a great demonstration. So I think what we should do is we've got the 3 watt on. Let's put a 20 watt LED on there, runs at a much higher voltage, and we'll see what we can get. So I'll just put that down. Take the 3 watt off. Okay, stick the 20 watt on, like so. Okay, 20 watt is on. So basically, let's let the power in. Okay, let's reconnect that up. Okay, so we're now consuming more power again back into the circuit in the capacitor, and we'll just basically turn this down until we get some sort of response. Yes, we have a response. Okay, down we go, brighter and brighter. Look at that blinding brightness. Okay, and as I said, I think with these higher voltage ones, we having even a lower resistance will even be better. Okay, so what I'm going to do now is we'll just we're disconnecting that. Okay, you see how quick that fades away because it's a higher thing. And let's put one of my favourites on. Okay, for this, which is this one, the 10 watt, but it's a lower. The lower voltage is they kind of last. They seem to work better. Okay, with a small amount of energy. Okay, so we collect that one on. Okay, and then basically we're going to turn it on like so. There we are. Powered up the thing, and we just turn this resistance down. There we go. On we go. Turn it up. Turn it up. See, that's really nice and bright. That's really bright. We really like that. Really like that. See that in the dark. Okay, and that's all lovely and lovely. So we can actually see there as well Lovely, lovely, lovely and bright. Okay, and as I said, with low resistance on there, we can get this even brighter, utilising more of this kind of power coming out of here. So this is an absolutely great demonstration, and I've actually, I said, one of these mounted a couple of feet away from the ceiling. Okay, acts as a pretty good light. I have two of these in one room in the cottage, and basically they provide all their lighting. And I have two settings, one light, one dark, and they work absolute treat. But they're not using a magic circuit, but they're using a sort of a different type of circuit. But yes, I thought I'll demonstrate that. And we can power 100 watt. Hang on. Right. What we have here now is the next generation in circuits and coils. And what we have here is a beautiful little unit, okay, which is different from the other one, because what we have here is we have, you can see on my finger there how small it is. This is a pot core with a 2-to-1 ratio, 80 winds 0.5mm wire and 40 winds of wire. The next generation of coils. And we've got 3-watt LED on here, and we've connected the electrolytic capacitor up to it, like we did with the other one. And we have a 10k ohm resistor, just like the other one, the fixed one. But we wired up slightly different, as in we have a resistor instead of in between a transistor base and one of the coil windings. We've actually got it before as well, and that actually does make a difference to performance. Okay. But it's the pot core really which is all the magic. Now, what I've done is I've used this kind of brown kind of wire stuff to twist it to try and tighten it, because I don't have any screws to tighten it. So we will able to hear the ringing, but that's good. It's good. We need to do this. As I said, this is the first generation pot core module. As I love these size boards, and I've ordered some yesterday, and they should be arriving in the next day or two. Okay, so I can continue this research and have lots of different ones. Okay, so I don't have to take them apart all the time and get loads more wires. So let's get it on. So we've got the battery, and we've got the same capacitor. We're just going to compare the run time with your one. So we're just going to literally just touch it. Okay. There we are. Look at that brightness. Okay. And then the camera's adjusted, and it's completely, there we are, free of a battery. And can you see how that frequency's changed? If you can kind of hear it. It's lasting a lot brighter, and it's running for a hell of a lot longer than compared to the other coil. Pot core is bloody brilliant, and it just goes on and on and on. Right, it's getting dimmer and dimmer now. Okay, but as I said, miles longer than the other one. Still going. Okay, and it's still 700 milli watts. Okay, yeah, still going. Let's have a little look around this beautiful little thing. Okay, the little pot core with a little grey box transistor, still running, as you see. So much better performance for these pot cores, I have to say, than any other thing. It is the magic. There, it's just died out now. So look how long that lasted compared to the other one. So absolutely superb, and that was just literally after one little, the same touch, the same amount of energy. So what I'm going to do is I'm going to end this one now, and then we're going to put a supercapacitor on there, okay, which can store a lot more energy. So I'll end this now. Right, da, da, da. Look what we have here. Okay, and I've got a nice little bag of these. Okay, these teeny little things are 5.5 volt supercapacitors. Look how small that is. And would you believe it that basically that one, compared to the electrolytic, this big electrolytic, this has 25 times more energy this can store than this. Okay, so pretty phenomenal in size reduction, if you can actually see. Okay, beautiful things, and you can put these in two in series, and you put them in parallel and all sorts of stuff. They're great. These are bloody great things. Okay, moving on to the other supercapacitors. Okay, so that has 25 times more than that one you've seen running. Okay, and then this one here, this one has what is it? That's four. Oh, this is 100 farads. Yes, this is 4 farads, and this is 100 farads. Okay, so that's 25 times more energy. But it's a lower voltage. It's 2.7, so it's 12.5 times more energy than that one. And then this one here, this beefy thing, that has 5 times more energy than that one. So I think that's like got over 125 times more energy than this. Okay, this electrolytic. Okay, so you know what I mean. So what we're going to do is we're going to demonstrate this one. Okay, this little baby on here. Okay, on this absolutely beautiful, and we can have it in our hand. Here we are. We can. This is a little thing, a little prototype module in the hand. All these parts can be very compact if it's properly sorted up into a proper little lantern or light or something. Okay, and we're going to be powering this thing off here and see how long it lasts. Right, okay. Now, these take up to 5.5 volts, okay, and just for the sake of ease for my hands, because normally it would be powered from the thermoelectric generator, but we're going to do it with this at the moment. Okay, so this is exactly 5 volts, right, and then what we're going to do is plug that in like so. Okay, so we're going to kind of charge that up and then take it away, right? Now, supercapacitors are a lot slower to charge than the electrolytic. Electrolytic can be instant, whereas this actually takes a few seconds to charge up, and then it's up to about a couple of minutes until it's finally charged. But from a thermoelectric generator, where you kind of leave it for a couple of minutes on, it's absolutely perfect for it. Okay, so let's connect it up. Right, here we go. Right, straight away, on we go. And you can see what happens is basically that is the capacitor actually charging up at the moment, okay, as that thing goes down. If we just that's really bright light as well. If we just take that out, so we've disconnected the circuit, and now it's purely charging that capacitor up, okay. And you can see it's 120 milliamps at the moment and going down, which is way lower than basically this puts out, which can put out up to 600 milliamps. Okay, so it's all very grand. So if we were we can charge things in a variety of ways. But as I said, it's this kind of time delay we have. But as I said, when you've got it on a pan, it'll be no problem. I think for these kind of ones here, these bigger ones here, then 5 minutes, yeah, should charge those up to max. But as I said, we have over 100 times the amount of energy. But for some reason, these work a hell of a lot better, these supercapacitors, than the electrolytic. I'm finding there's something really special with this circuit. So I'm just going to end this now. Right, so basically we've now hit 0. Okay, so it hasn't consumed any more after a couple of minutes of charging. Okay, and interestingly, it doesn't, even though this contains 25 more times than that, it doesn't seem to make a difference in the time. It's just a nature of the supercapacitors; they take a couple of minutes to charge up. Okay, so basically, completely disconnect this. Okay, so that's kind of replicating the actual thermoelectric generator. Okay, which we'll do, say, tomorrow or something, and then we're just going to connect this up. Okay, there we are. Look how bright that is. Okay, that's a bloody great light. That's a lovely light. Okay, really, really bright. You can see by the dimness. So the great thing about this is, from that teeny little thing there, you know, which is about smaller than my thumb, miles smaller than my thumb, basically that will run for an hour. This will run for an hour off that. Okay, that's fucking amazing. Don't you think? So compared to this other one, this one which is massive, this, you know, which runs for about a minute on this really good thing, this one, it lasts an hour. Okay, and that'll just run and run and run and run. Okay, and if that's not something to do with free energy, I don't know what is, because that is not connected to any battery source. There isn't. Right. So while this is running, you can hear a noise come out of it. That's the resonating frequency between the magic circuit, the capacitor, and the LED. Okay. Using the beautiful magic pot cores. This is the first one I wound, and the results from it were absolutely spectacular. And it was like revolutionary compared to normal capacitors. It absolutely is. It's basically gone. I've gone on to a whole new level now. Okay, that's bloody grand. It's great considering this teeny little thing runs for an hour. And I said we have much bigger ones, okay, as well. So we've already reached the magic lantern, the specs I kind of wanted, which is great. And the point is, I know I can make even more improvements, because I'll show you this this next one, okay. So this one here, this is the Generation 2 pot core, okay. And this pot core is much smaller than this one. If we can actually see hang on, that light's getting in the way. Okay, so we can see this pot core here compared to this size one. So that's my finger. See the difference. With this one, what we've got is we've basically got the much smaller wire, 0.25 mil wire, and we've got 120 turns. Okay, and it's a 1-to-1 ratio, a bit like a vortex coil, to try with this new wire. So whereas the 2-to-1 ratio may work even better. But yeah, lots of, when you go small coils, more winds, and then that increases the inductance. And this one is a special upgrade, is we have a switch here, and we can switch it from 10k resistance, okay, down to 1k resistance, okay. So we have two light settings, okay, and basically I've charged this one up, okay. It only takes, for most of the power, it only takes a few seconds, okay, and then just to get so it's completely full up to about 2 minutes with this one, but it seems to be the same with all the supercapacitors. So what we'll do is we'll connect that up, and then we can directly compare them. Okay, and here we go. On we go. Look at that brightness. Okay, now this one is actually a lot brighter than this one. Okay, it's difficult to tell here because it's both bloody bright. But this one is much more efficient, okay. This small coil is so much more efficient than the larger one with the less winds. Even though this one's bloody grand, but this one's fucking up another level as well. And this is really, really bright light. And if we do the switch, right, you could it's really fucking bright. That's bright. Literally, I can light up a lot of the most of the room with this one, okay, and we can switch it down there. Unfortunately, you can't see that difference because of the brightness setting with the camera. So let's go over here. All right, okay, that's the kind of brightness compared to that one. And as I said, we can easily see our way around the room, and it provides shitloads of fucking light. Okay, if we can shine on there. Right, okay. And then let's do the next brightness setting. You see the difference? Now you can see the difference. Okay, so that's that setting, and that's that one. And as I said, this has got no reflector or anything. So that is a very, very fucking great light, okay. And as I said, this will run for an hour as well. So we have two wonderful, wonderful, wonderful two kinds of lights. So I think this is the end of a spectacular whole new world of resonating technology, because basically we have a tank circuit, self-resonating circuits here, which are just constantly recycling the energy. And the thing is, I know I can make even more improvements, because the actual the most efficient way of using that coil energy, the resonating coil energy, and this is all backwards electricity, is by having a third winding with a bridge rectifier. And it got some amazing results. So we've got that to do, but I have to wait until the prototyping boards come. So I am really, I mean that's just like a lush kit, you know. And there's nothing like this in the world. Okay, nothing at all. Okay, and this is just in 2 days, couple of days progress, but with a brand new pot core stuff, and it's absolutely brilliant. Okay, yeah, we'll give that one another blast of its power settings. Okay, absolutely beautiful and really stable. And all the transistors are really cool, okay. And also I can try different kinds of transistors as well, okay. There's all of that sort of stuff to do, and crystal cells, and also Peltier TEG elements and cold fusion, and you name it, man, is all happening. So I'm going to say good night tonight, because I really have to get some good sleep. So I'll leave you there, and we'll do a couple of more really interesting ones tomorrow. Okay, so from me, good night.